Okay, I think that's everyone through the waiting room. So thank you very much for coming. My name is Joseph Parker. I'm a research fellow at ICHEC, the Irish Centre for High-End Computing. And with me today is Pablo Loret, who is a computational scientist. And we're here to tell you about the different activities that the centre does. Main one being to run the national HPC facility. So Pablo is going to start by telling you about that, and then I'm going to tell you about the other activities that we do as part of ICHEC. Okay, Pablo.
Perfect. Thanks, Joseph. Hello, everybody. My name is Pablo, and I'm just going to start by giving an overview of ICHEC, who we are, what we do, and how we're here to help researchers in Ireland. Then I'll talk briefly about K, which is Ireland's national supercomputer, which ICHEC manages. And then I'll go on to talk about the national service, which is where I work within ICHEC and how we support researchers in Ireland. So ICHEC, we are Ireland's national HPC centre, high performance computing centre. We're hosted by the University of Galway, and we're funded by the Department for Higher Education, Further and Higher Education, Research, Innovation and Science. We provide e-infrastructure, services and expertise, and I'll go into that in a second. We work mainly with academia, but we also have partners in industry and in the public sector. We have offices in Dublin and in Galway. And then our cluster that I'll talk about in a second is hosted in Waterford. And the centre is, we have 45 staff in the centre right now. We have system administrators, computational scientists, scientific researchers, administrative staff, etc. So let me talk to you about K, which is Ireland's national supercomputing facility that ICHEC manages. So K is made up of four main components. And the main component is the thin or cluster component. So it's composed of 336 nodes. Each of these nodes is composed of 40 CPU cores. And these are Intel Xeon Gold 6148 CPUs. Here are the specs if you're interested. We also have a shared memory component. It's a smaller component, so it's 6 nodes, again, each with 40 cores, CPU cores, same CPUs, but this component, the cores in this component have access to much greater RAM and storage. So this is for memory-heavy jobs. We also have a GPU component, which consists of 16 nodes, and these nodes have the same specifications as those in the thin component. But this time, each node is also equipped with 2 NVIDIA Tesla V100 GPUs with 16 gigabytes VRAM. And then we have a service and storage component, which is a set of service and administrative nodes that we use to provide user login, batch scheduling of jobs, management, networking, etc. So now I'm going to talk a bit about the national service and the user support that we offer. So this is where most of my work in ICHEC would be. So the national service is the primary mechanism through which researchers gain access to computational resources. We provide user support. So we do this in the form of a help desk. So if you're a user, you're using K and you encounter any issues or you need any help because you don't know what's happening, you're getting an error, you need to install some software, you need to license a software that you've downloaded, we're there to help. You can log in a ticket and we'll be emailing you to help you solve your issues. We also can also help with code development, mainly in the form of profiling, optimization, and porting to make sure your code is good for running on HPC. We also provide scientific expertise, and we have a number of collaborative research projects, both within academia, also within industry, but also with international partners. And we also provide application support for project calls such as PRACE, Euro HPC, SFI projects, etc. So how does one access these HPC resources that the National Service provides? So the first step is to register an account. And to do this, you go to register.ichec.ie, you enter your details, and then you get an email with instructions of how to proceed. And in that email, they'll talk about the different avenues. So there's two main avenues to access these resources. The main one is to apply for an ICHEC project. So we have three different types of projects. The smallest of these is the Class C. This is a 1 year long project, and you'd be allocated 100,000 CPU hours and 250 gigabytes storage. And this is the kind of project we recommend for new users or users who are testing some code for the first time. It's more of an exploratory project. Then we have Class Bs, which are go on for 1.5 years, and you'd be allocated 1 million CPU hours and 1 terabyte storage. So this is a much bigger project in the Class C. So we recommend this for maybe once you've familiarized yourself with K and your code is ready and you know what your research is going to look like. We recommend always going B or above. And then we have the Class A, which is a high impact 2 year long project consisting of 10 million CPU hours and 5 terabytes storage. So that's the main avenue, the projects. There's the other avenue is condominium access. So there's a number of Irish third level institutions have condominia within K, and these are just partitions of K that are assigned to these institutions and are managed by these institutions. So Maynooth has a condominium, and the way to access this is by emailing the institution's contact point, which is Vanoosh, whose email I've left here. So if you want to access the condominium, you email Vanoosh, request an access. Vanoosh will email us, and we will approve this access. And the resources of the condominium are more modest. They are mainly just for familiarizing yourself with K, how the queuing system works, how to navigate the system, how to load modules, etc. But then if you want to do heavy calculations, we always recommend going for a project, as the resources in the condominium are shared, whereas a project would be for you and your team only. So here I just have some figures with some data for the 2021-2022 period. So in this period, K had 850 unique users coming from 23 different higher education institutions. There was a total of 835 projects running on K, which added up to more than 160 million CPU hours. And within the help desk, we resolved 3,100 tickets in that year period. And here I just have a chart to show you the different scientific disciplines of the projects that were run on K. So as you can see, the main bulk is chemistry, engineering, and physics, but we also have a number of life science projects, computer science, earth science, astrophysics, and mathematics projects running. Here you can see the number of publications citing ICHEC per year. So we do ask that you please acknowledge ICHEC if you have used any of our services to aid in your research. And as you can see here, in the years 2020, 2021, 2022, we had a lot of publications citing us. So we are providing services to a lot of researchers that are publishing their research, and it's good to see. It's nice when they acknowledge us in the papers, and we can put this in our website. So let me just, before I pass on to Joseph, mention that K is going to be decommissioned after the end of November. And our new system that Joseph will talk about is not going to be up and running immediately afterwards. So in this period between K being decommissioned on our new system being procured and set up, we're going to have a period that we're going to call the interim national service. And in this period, we will still be considering new applications, just as we always have. Applications that are already running will be honored. We're not just gonna, shut down K and end all the projects that we're running on K. That's not going to happen. And what we're going to do is that K is going to be running partially. So we're going to shut down part of K, and only 25% is going to be running. And the Class C projects are going to continue to run on K. Now, the bigger Class A and B projects are going to be moved to European machines, and the details for this are still to be confirmed. However, in this interim project, we are still providing technical support to all projects. We're still providing, the help desk will still be open. We'll provide the same services, and we in ICHEC have staff time allocated to support users in this transition. Just look out for future seminars, because some ICHEC staff are going around the third level institutions of Ireland, talking about the details of this interim national service period, how is it going to work, how these projects are going to be migrated to European machines. And I believe there is arrangements happening to get one of these roadshows discussing the interim national service at Maynooth University. So look out for these. And that's all from my side. I'll pass on to you, Joseph.
Thank you, Pablo. Yeah. So I'm just going to take you quickly through the other activities that ICHEC offers. Let's see. Share my screen. Start in the right place. Okay, so we also have a remit from government to do other activities. So one of the main ones is training and outreach, which we provide through sort of professional training courses to academia, industry, and the public sector. We also provide graduate level teaching at various universities. So typically courses that are HPC oriented, so parallelization paradigms or GPU programming, or language-based programming like Fortran or R, software carpentry. And as we're staffed by computer scientists, but also people with an academic background, and we have people working at the forefront of those fields, we also provide some domain-specific teaching. So particularly in things like data analysis or machine learning, AI, we do some teaching there. The resources to see the courses we offer I've included the links here. So we do training on our own, but we also take part in training on a European level through EuroHPC, which is the network of European computing centers. I would really recommend that link, because there is some really high quality training available to academics there. We also have an announce list that you can be subscribed to. So here's just some examples. I've just included them so you can see the blurbs of the kind of things we do. So HPC, intro courses, stuff on Linux as well, at various different Irish universities. So we also take part in outreach. We usually have a stand at ISC and SC, the big supercomputing conferences, and we've taken part in various other outreach events, and again, the details of those are on our website. I think Pablo mentioned this. We have our performance engineering group. So we can offer code optimization, profiling, and tuning as a service through the national service. Also, porting from CPUs to GPUs is something we have quite a lot of experience with. We provide this through the national service, but we've also provided it through specific funding calls. So last year we had a program called the Academic Flagship Program, and the goal of which was to prepare academic codes for Tier 0, or sort of the largest sets of machines. So we took academic codes that were running on Tier 1, so national HPC facilities like K, and optimized them. In some cases, we did different things, but in some, optimized them, and in some cases, we ported them to GPU so they could run on larger computing systems. We also have expertise in novel technologies. So at the moment, we've got quite a few people working on AI, things like computer vision, autonomous vehicles. And we've also got a rapidly growing group on quantum computing. So that's an area of active research within ICHEC. The other area where we are very active and have been very active for quite a long time is Earth observation and climate. So we work quite closely with Met-Erin. We have projects writing and optimizing code for them. Previously, we would run the weather forecasts on K before that got taken in-house. And we've also done simulations, that contribute to things like the IPCC reports. A lot of our work is academia focused, but we also want to promote the adoption of HPC beyond just academia, so in industry and in the public sector. And we have actually, over the course of the near 20 years that ICHEC has been around, we've worked with over 50 different companies and a wide range of different fields, just to help them use HPC, help them develop projects. And we have a specific program called the SME Accelerator, where ICHEC staff are actually embedded, physically collocated in a company for around 6 months. So you're not only helping them work on their problems, but you're there as a physical point of contact. So these are kind of the other services we provide. But sort of looking forward to the future, I should say more about Caspia, the new machine that is coming online to replace K. So just to give some context to this, I kind of hope the story we've told you about K, or any experience you've had with K, you'll recognize that it's quite a conventional machine. So it's, if you like, traditional HPC. It's mostly CPUs with a bit of GPU acceleration. It has mostly been used by academics and typically in the physical sciences. But this is not the way that HPC is going. So you've probably heard people talk a lot about digital twins. And what people mean when they talk about digital twins is thinking about sort of the evolution of modeling. So instead of having a model that is very self-contained, you actually want to tightly couple your model to the physical system that it is modeling. So you would have a model that monitors and predicts and controls the behavior of the system you're studying. And you can kind of think about this really for anything that you might want to model. So for example, in climate modeling, you can imagine just doing a CFD simulation to try and understand the climate. Or you can think, well, I've got all these satellites and I've got all this data coming from different places. Can I draw them into my simulation and improve my simulation and make predictions? And this sort of extends beyond just academic problems. Like you might think, if I'm running a hospital, if I've got a patient that comes in at a certain time of day, should I be doing different things with them based on the current situation in the hospital? And so you can develop quite tightly coupled models really for almost any problem you can think of. And so this means that in the future, when we're doing modeling, we are thinking of having a greater reliance on data. I talked about you need data from satellites, or that comes from lots of different sources, lots of different patterns of access, lots of different data formats to deal with. So there's a reliance on data, how to bring it into your software, how to assimilate it with your running code, and how to use that to then drive changes in the physical system that you're modeling. This also involves needing to deal with complex workflows, because the simulations you run might change depending on the state of the system. You might have made a prediction that was bad, and then you realize, oh, I need to update my AI model to improve the prediction the system makes. So there's a lot of work around controlling complex workflows. And then on the hardware side, there's going to be a greater reliance on GPUs as opposed to CPUs. And there's sort of a political steer towards making sure we have an impact in wider society, so business and public sector and government, as well as academia. So that's the context that we're working in. I've left some slides, and I'm not going to talk over them because of time. But just to say, these are things we're thinking about. We have a program called the Digital Innovation Flagship that is currently running from October this year to October next year, and there probably will be another iteration come next October. And the purpose of this is to create flagship projects that are able to build complicated workflows, but also for us to develop the expertise, develop the tools, so that we're able to do these things when Casper comes along. And so this is sort of the thinking that's shaping the procurement of Casper. So Casper, like I said, it's the successor machine to K. It's one of 5 new HPC systems that have been procured as a partnership with EuroHPC, so European Commission funding, and the Irish government. And it's designed to be a mid-range platform. So like K, it's a stepping stone from university clusters to exascale systems or pre-exascale systems. In order to achieve these this sort of advanced workflow, there's a big focus on making sure that the system can use data to be able to sort of interface with other services, other data providers, and to provide data storage where that's not possible. It is a reasonably small machine, so it's still only 15 petaflops in total. 10 of those are going to be provided by GPUs. There's also going to be a focus on containerization that hopefully will allow us to be able to provide an environment that will make it seamless for people to move between using Casper and other machines. But ultimately, this is, as well as having these new services, it's still going to be Ireland's HPC facility, and hopefully it will still be the familiar platform that users are used to. We're still going to have the same access patterns, so you still have the same periodic calls to get access through Class ABC projects. So that's all I really had to say. Besides that, as an organization, ICHEC is growing. I think we said we had 45 staff. It's kind of rapidly approaching 60. And we're always keen to talk to people who are enthusiastic and would like to work in this field. I didn't really know when I was finishing my PhD that there was a way between academia and industry, and I found working at ICHEC and at other supercomputing centers, it's a really nice blend of academia and industry. You get your choice of working in Dublin or Galway, and it's a lovely bunch of people to work with. So if you are interested, keep an eye on our careers page, or drop an email to recruit.ichec.ie. Even if we don't have jobs available, we're always interested in talking to people. Okay, so thanks very much for your time. And I think we're going to pass over to Roberto and then deal with questions at the end.
Thanks. Can I go ahead, Heidi, or are there questions for ICHEC now?
Yes, I think you can go ahead there, Roberto, and then we can do questions at the end. Thanks.
Okay, nice. Right, so you should be seeing my screen now. Good morning, everybody, and thank you for joining this call this morning. Here I'm going to my name is Roberto Sabatino. I'm from HEAnet, and my role is Research Engagement Officer. And it's really all about, my role is all about how can HEAnet support researchers in Ireland, and really with the ultimate goal to make sure that your research is successful. So the talk covers three aspects. The first part is an overview of the HEAnet services that you can avail of, which are off the shelf, nothing special. And then we go into more ad hoc specific things where we can help you with your research. So collaboration and funding opportunities there. And then the specific work that we're doing to support open science, which may be of interest to you. So first of all, who are we? Many researchers don't know of our existence, although you use our services pretty much every day. And the things that in my experience, researchers are mostly aware of, without knowing that they come from HEAnet, is Eduroam, for example, where you use your Maynooth University credentials to access the Wi-Fi both at Maynooth, but also if you are visiting another university in Ireland, you can access the Wi-Fi there by using your Maynooth credentials to access the Wi-Fi in UCD, ICHEC, UCC, and so on. And this is a service which is controlled in Ireland by HEAnet and adopted by all the participating organizations. The other one is FileSender, where you send large files between sites without being constrained by the limits of file sizes that you have in normal email. And the third one, which you might be familiar with, is Edugate. Edugate is, in a way, an extension of Eduroam in that it allows you to use your home credentials, your Maynooth University credentials, to access web-based services hosted by other institutes. So if there is a web-based service, say access to a library, access to a resource at another university in Ireland, you can access those using your Maynooth credentials. At the basis of everything we do, though, really is the backbone, which is essentially a network infrastructure which connects up all the universities, research centers, technical universities, and other HEIs in Ireland. We have this dedicated infrastructure which is based on a fiber-based network between these locations across the country, and we manage the fiber which we have procured from the market. We deploy our own equipment on top of this network to offer services to the universities. And the services that we offer are primarily connectivity. So the normal IP it's what you use to exchange emails. It's what we're using now for this Zoom call, and so on. It's what you use when you use file sender. But we also have point-to-point circuits, and these range in capacity from 1 gigabits per second to 10 gigabits per second. And if you think of a point-to-point circuit as a service where you have two research infrastructures or two laptops, to keep it even simpler, say one at Maynooth University on your desk and another one at UCC on your collaborator's desk, and they appear to be in the same room, on the same LAN. Okay, and these services, as I said, range from 1 gig to 10 gig, and they are national in scope, but also international in scope, and more on that in a few minutes. And they're typically used to connect sites, to connect test beds, and to connect research infrastructures in general. The concept of point-to-point circuits is expanded further by the concept of virtual private networks. Now, you may know the concept of virtual private networks as giving you extra security for accessing resources. That is one application of VPNs, but it's also where I explain the point-to-point circuits in terms of connecting two sites, remote sites, so that they appear to be in the same room. VPNs connect multiple sites, and again, they are there to connect multiple sites to appear, to give more security, but also to make them appear as in the same room, so that they can connect test beds and research infrastructures to conduct research in networking as well. I mentioned about the international scope, so we rely on HEAnet primarily for our international connectivity, and the HEAnet is a pan-European network which connects up all the national networks that we have in Europe. So HEAnet is the Irish National Research and Education Network that connects up all universities. Every country in Europe has a similar organization and a similar construct, offering similar services. And these are all interconnected by a pan-European dedicated infrastructure that connects them all. So the services that we offer in Ireland can be extended all the way to other countries in Europe. This is why, for example, you can use Eduroam in Italy, Spain, Germany, and so on. It's why you can extend your point-to-point circuits between Maynooth and another organization, another university in any other country in Europe. Gets better because it extends globally through this global interconnection map that HEAnet manages for the European countries, for the European NRENs. So you see a link, for example, to Rio here in Brazil. But in Latin America, there is a similar construct to HEAnet in Europe, which connects up all the national networks in Brazil, Argentina, Bolivia, Uruguay, etc. And therefore, it means you can collaborate with researchers in any one of the Latin American countries. And this then, from this map, you can see how the global reach of the connectivity for research and education that we have through HEAnet. Here's an example of an application of a point-to-point circuit at a European scale. These are the radio astronomers. So in Birr Castle, there is a radio telescope which takes pictures from the sky, and these other sites do the same. And all the data that is collected by these radio telescopes is sent via 10 gigabit links to a central correlator in the Netherlands, where all the data from the various observation points is analyzed and correlated, and they come up with their science. Okay, these are all at 10 gigabits. Another example is a collaboration between Trinity College Dublin and UFES, which is a university in Brazil. They are doing research in networking, and they have connected research infrastructure, so networking equipment in Trinity, in UFES, and also across sites in Europe in a virtual private network via this construct. And this just shows that it uses the international global connectivity resources that we have that I showed in the maps earlier. Another service which is of extraordinary value to the researchers is our brokerage for cloud services. So if you find yourself in the position to need to procure cloud services to conduct your research because it exceeds the thresholds over which you need to do a procurement, you will know that procurement is very time-consuming. It's very difficult. It requires a lot of expertise and a lot of stakeholders, and it takes away your time from doing your research. So what we have done in HEAnet, we have partnered with our collaborators in HEAnet, and we have gone to market representing all of the universities across all of Europe, which has put us in a very strong negotiating position with the cloud service providers in Europe. And we have been able to broker framework agreements from the market with very advantageous terms and conditions, very good discounts, and also if you look at network egress costs, we have very favorable conditions for network egress costs. Sometimes they are waived altogether, and in some cases they are capped at 15% of the total bill. In practice, what this means is that if you need to procure cloud services, you actually don't need to procure. You can just call off our framework agreements and use the providers of your choice. Now, depending on the value of your procurement that you need to do, you might need to do a mini tender, but a mini tender takes a few days to run, and then you can avail of these services from any one of these providers that we have listed here without having to run a public procurement, because we've done all the groundwork for you. Yeah, so that's this summarizes the main basic services that we offer to researchers to support your research. In this picture here, you can see, well, the whole suite of services that we have to offer. There's lots of things there, but I focused on the ones which I felt were the big hitters, the ones that are mainly used by researchers. So I know we have questions here, but I'll keep them to the end. This is the first part on our basic services. I'm going to look at collaborations. So we're very interested in having direct collaborations with researchers and research support staff at universities. Being a networking company, we focus on things: networking, security, identity management, because obviously if we want to develop things, they have to be on topics of mutual interest, and this is where our interests lie primarily. But we can also look at piloting of new services in different research domains. Say if you are from material sciences, right? We're not material scientists, but we are developing services that are beneficial to material scientists, for example, in the area of storage. Or if you are in the field of energy distribution research, well, that's not our field, but we do have services like time and frequency information, which are relevant to energy distribution. And we do have collaborations with other institutes in these fields. So if you are from a domain and you think that we have a service, or we could potentially develop a service that benefits your research, then we can talk and we can look and we can progress this discussion. These are two very concrete examples that we have going on at the moment, and I will speak more about the first one later on in this talk. We also look to support your research by assisting you with research infrastructure development. So if you are looking to build a research infrastructure, we can help you with that, give you our advice, make sure that you don't overlook networking costs, or indeed that you are aware of the services that we have that might contribute to your research infrastructure development. And as part of this, we look at reviewing your research and science workflows to see, well, how can we help with our services in your workflows? The big example that I always refer to that dates back to more than 20 years ago now is the radio astronomers. I showed you the picture earlier where there's a network between the radio telescopes and the central correlating center. Well, 20 years ago, there was no network between the observation points and the correlation. point, the connectivity was done by lorries with tapes, right? So at each site, they would take pictures of the sky, they would download all the data onto tapes, truckloads of tapes I'm talking about, and then these trucks would drive from Beercastle to the Netherlands, and you can see just the logistics of that, the dead on arrivals and the delay, the lag in the outputs from the observation. We worked with them, we networked it, and that science has now gone from months of delays to near real time. So we're very happy to have these conversations with you about your workflow and see how our services can improve your workflow. Another thing we do is support you in funding proposals. So you're well aware of the EU funding proposals, and you don't need our help in responding to those unless there is a research infrastructure component. But we also have access to information about additional funding proposals that are not directly from Horizon Europe, for example. So we have HEAnet who have calls, open calls. They have funding that they can allocate to research institutes. In the case of HEAnet, it's they're normally worth up to 30,000 euros. And it is through the HEAnet Innovation Fund. And again, these would be funding projects which are relevant to HEAnet, so relevant to HEAnet. And again, they would be in the fields which are relevant to networking, so identity, trust, networking, security, those fields. There's also funding calls through EOSC, which is the European Open Science Cloud, which have funded a call, several calls now, for the uptake of cloud service, of commercial cloud services. And what this means is that I showed you the cloud service providers that we have through our framework agreements. There have been cloud funding calls where you could be awarded vouchers to spend with those cloud service providers. There's been several calls. In total, around 14 million euros has been awarded across Europe in the last few years. And around 2 million euros of that has come into Ireland through our engagement, right? And that just shows you the impact that this engagement can have, because I said 14, it was actually 9, around 9 million euros across the whole of Europe. 2 of those 9 million euros have come to Ireland through a succession of calls. The latest in 2022, Galway, Trinity, and UCC were awarded 1.1 million in 2022. And this year, in 2023, we've had MTU and UCD awarded these amounts of money. So we're close to 2 million euros. So we can help you with those. We make you aware of them, and we can also help you in your applications for those funds. Okay. What else do we bring to the collaboration? Well, we bring our infrastructure and expertise, but we also bring data. We have access to NetFlow data. So if you understand what NetFlow data is, I won't go into that. It's all about collecting communication data that crosses the network. That is a gold mine for anybody who does research in networking, security, performance, routing protocols. And this data helps with that type of research. And we have that, and we can share that with you. And we also look to host postgrads, and we can do that directly to work on projects of mutual interest. But we are also a member of the advanced CRT, which means we can host postdocs, postgrads, sorry, I should say, postgrads through that, the advanced CRT program. The other thing we do to support research is to support research support. And this is our raising work that we have. And raising really is a forum that has been set up, and it brings together research IT staff, research office staff, and library staff, because especially when it comes to data management, these are all key stakeholders, and they need to work together to support researchers. And there was no forum in Ireland where these 3 stakeholders could come together. They didn't even exist. They don't even exist at an institutional level in many cases, let alone at a national level. And by bringing them together at a national level, we are also encouraging the bringing together of these at an institutional level, so that dialogues can happen between these 3 stakeholders and with the researchers so that they are in a better position to support researchers. And what we're doing here in this forum is sharing good experiences. There have been numerous workshops on good cases, things that people are proud of what they've done at their institute, and share this information with the forum so that other people can be inspired by it and do the same in their own institutes, and collaborate on common challenges. Now, one thing that, well, I've spoken about the events of good practice, but we've also worked together on the development of a North proposal, which I'll speak about shortly. And we are developing a maturity assessment model for research support at HEIs. And here you can see a picture of one of these such workshops. You might recognize somebody over here. Right? Anybody who gets the name right, well done. And also common approach to research management services. I showed you our brokerage for cloud services earlier. Through the work in the Resin Forum, we are now looking to broker for research management services. So repositories, ethics management, grant management, metrics management services that are all relevant to research management. So that's the part there on supporting research. Now I'm going to go on to supporting open science and open research. So in Ireland, we have the NORC, which is the National Open Research Forum, which has set out an action plan for Ireland to move towards open research. And at international level, there's also the EOSC, which is the Open Science Cloud, which is doing pretty much the same, but at a European level. So open science, of course, there's a lot to it. There's open access, there's policies, there's skills, and where does HEAnet come in? We come in from the infrastructure point of view, and the services which support data management, which are all part of the big vision of open research. And as part of that, through North, we have availed of funding to develop a pilot for a shared storage service for active research data. And this is called IRL-DAT. It's a project which has been awarded, well, it's a 2-year project, started last November, and it ends at the end of October next year, so we are pretty much halfway through. And the partners are HEAnet. I'm the coordinator of the project. We have ICHEC involved, our colleagues there. And we have UCC, UCD, SETU, and EUDAT. I will speak a little bit about EUDAT in a minute. And we have several use cases from a variety of disciplines. We have, as I said, the material sciences are a use case of this pilot, and institutes. We don't have anybody from Maynooth, but we are very open, very keen to get somebody from Maynooth also involved as a use case, as a pilot user in this project. The final outcome of this pilot would be the definition of a production quality sustainable national service. It won't be the implementation of one, because we only have 200,000 euros funding, so there's no way we can implement a sustainable national service. But from this pilot, we will learn what it takes to offer one, and we'll come up with a definition of production quality service. Also, in the last year, we also lobby for funding for a production quality service, but we don't have that just yet. And this is what it looks like, the pilot. So the pilot is being based on technology and services which are offered by EUDAT, which is a European consortium of research institutes who have developed a set of services that cover the whole life cycle of research, including the active phase. And we're focusing on the active phase, which is essentially sync and share services. And so we have, first of all, gained experience with using these services on the European infrastructure. Our pilot users have used those services to test their fitness for purpose. And then we have deployed those services on national infrastructure in Ireland, in these locations. And we are in that phase now where we are, the pilot users are using this infrastructure, which is the services developed by UDAT, but rather than being in Europe, they are national infrastructure. And then in the third phase, we have the, which we are starting right now, is the definition of the production quality service based on what we learn in this phase 2. We have 11 use cases, which, as I said, come from a variety of disciplines, a variety of institutes, but as yet, nobody from Maynooth. And we'd be delighted to have somebody from Maynooth as well. We also have the EOSC Ireland group. So I spoke earlier about what's happening, the forum which exists nationally, which is the National Open Research Forum, which is driving the agenda for open research in Ireland. And at a European level, we have the EOSC, which is driving the advancement of open science at a European level. And but it's odd that the two didn't have a very strong coordination between what was happening in Ireland compared to what's happening in Europe. So we have set up the EOSC Ireland group, of which I run it, which is to do exactly that, coordinate between the national initiatives and the European initiatives. And you can join this group by sending me an email, and it's all about the flow of information, sharing information, and contributing to each other to advance open research nationally and internationally. So that is pretty much all I had. I did want to just share this form with you, which is a survey, actually, because if you want to know more about opportunities for funding or initiatives that we have, I need your permission to send you an email about it. And through this form, you can give me that permission, and you can also answer. It takes 2 minutes to fill in. There's literally 4 questions. And if you provide your email address, it means I put you on my database and I can contact you proactively on initiatives that may be of interest to you, especially, for example, for cloud funding opportunities. And that's all from me. Thank you very much.
Thanks, Roberto. That's very interesting talk there, particularly in terms of the HEAnet service offering. I wasn't aware of half the stuff you're doing, really, particularly the brokerage services. I am, of course, personally aware of the EOSC Ireland project and your IRL DAT project, and I know that I am actively trying to find an MU use case for you in that regard, because I think the IRL DAT project is something that's very personally interesting for me. So we have a